Chapter 11, Chemical Reactions. This will help you learn about the 3 different parts of chemical reactions, balancing reaction equations, and the 5 different types of chemical reactions. And here are a few definitions that you'll need to know. An element, which is the most basic form of matter. A compound, which are 2 elements bonded together. And a chemical equation, a representation of a chemical reaction. Here are the 3 main parts of a chemical equation. Reactant, which is on the left, the compound or elements being combined. On the right, you have the product, which is being made after the reaction is complete, and the yield sign, which is the sign used to show that a chemical reaction is occurring. Balancing an equation. The only way to balance a chemical equation is by placing coefficients in front of the elements and compounds. And here's an example of this, of an unbalanced equation. H2 plus O2 yields H2O. In this equation, there are 2 hydrogens on each side, but 2 oxygens in the reactants, and only 1 in the products. And this leads us to the law of conservation of mass. This law is in place so that no mass is neither made nor destroyed, keeping things equal on both sides of the equation. But why is this important? This is extremely important because if you balance an equation incorrectly, it will be a totally different substance, which can be very, very dangerous in real-life situations. And here's an example of one of those situations. H2O, which is water, and H3O, which is hydronium. The difference is that H3O is more acidic than H2O, according to the pH scale. But this is how you'd balance this equation. You'd place a 2 in front of the hydrogen and a 2 in front of the water. Now you'd multiply the subscripts to the coefficients. You have 4 hydrogens and 2 oxygens on each side. Now there's a balance between the reactants and the products. And that begins us with our first reaction, the synthesis reaction. This reaction is where 2 or more elements or compounds make one big compound. And this is how you would do this. The general formula for a synthesis reaction is A plus B yields AB. And here's a big example. Fe plus O2 yields FeO2. The small reactants become one large product. And now, decomposition reaction. This reaction is where one large reactant is decomposed into smaller products. Now this is how you would solve a decomposition reaction. AB yields A plus B, which is the complete opposite of a synthesis reaction. Now here's an example of a decomposition reaction. Sodium chloride yields sodium plus chloride. The big compound is broken down into 2 smaller parts. And now moving on into the single replacement reaction. This is where 2 parts of a chemical reaction switch places. And this is the general idea of what you would have to do. AB plus C yields CB plus A. Now here's an example of a single replacement reaction. Zinc chloride plus copper yields zinc plus copper chloride. The zinc and the copper switch places to make a different compound and an element. And now moving on to the double replacement reaction. This is the same idea as the single replacement reaction, but it has 2 compounds in the reactants instead of a compound and an element. And this is how you would solve a double replacement reaction. AB plus CD yields CB plus AD. Same general idea as a single replacement reaction. Now here's an example. FeS plus hydrochloric acid yields H2S plus FeCl2. The Fe and the hydrogen switched places. And finally, the combustion reaction. When a carbon, hydrogen, and oxygen react and produce CO2 or carbon dioxide and H2O or water. And this is how you would solve a combustion reaction. As long as you have carbon, hydrogen, and oxygen, you will always get carbon dioxide and water. Now here's another example of a combustion reaction. CH4 plus O2 yields CO2 plus H2O. Since you have this carbon, hydrogen, and oxygen, you will always get carbon dioxide and water. And these are all the major things that you will need to know to completely understand Chapter 11 and all about the chemical reactions and how to balance them.